Today, we delve into the fascinating discovery of EGS-zs8-1, the most distant starburst or Lyman-break galaxy ever observed. EGS-zs8-1 is a remarkable galaxy situated approximately 13.1 billion light-years away from Earth. This means that we are observing it as it existed just 670 million years after the Big Bang, during an epoch when the universe was in its infancy. The discovery of EGS-zs8-1 provides a unique glimpse into the early stages of galactic formation and evolution. A starburst galaxy is characterized by an exceptionally high rate of star formation. EGS-zs8-1 is no exception, as it is producing stars at a rate several hundred times greater than that of the Milky Way. This intense star-forming activity is often triggered by external factors, most commonly interactions and mergers with other galaxies. The presence of such a vigorous starburst phase in EGS-zs8-1 suggests that galaxy interactions were occurring very early in the universe's history. But what exactly is a Lyman-break galaxy? These galaxies are identified based on a drop in their light spectrum at the Lyman limit, which occurs at a wavelength of 91.2 nanometers. This drop, or break, is due to the absorption of ultraviolet light by neutral hydrogen in the intergalactic medium. Lyman-break galaxies like EGS-zs8-1 are crucial for studying the early universe because they are bright in ultraviolet light, making them visible across vast cosmic distances. The detection of EGS-zs8-1 has profound implications for our understanding of galaxy formation. Its high star formation rate indicates that significant amounts of gas were being funneled into the galaxy, possibly as a result of mergers with other young, gas-rich galaxies. These interactions could have ignited the starburst phase, leading to the rapid creation of new stars. This process highlights that galaxy collisions and mergers were likely common even in the early universe, playing a critical role in shaping the first galaxies. Moreover, studying EGS-zs8-1 helps astronomers learn about the Reionization era, a pivotal period in cosmic history when the first stars and galaxies ionized the intergalactic medium. By examining galaxies like EGS-zs8-1, scientists can gather data on the properties of early galaxies, their star formation rates, and their role in reionization. The discovery of EGS-zs8-1 was made possible by combining observations from the Hubble Space Telescope and the Spitzer Space Telescope. The advanced capabilities of these telescopes allowed astronomers to peer deep into the universe and detect the faint light from this distant galaxy. Future observations with next-generation telescopes, such as the James Webb Space Telescope, will provide even more detailed information about EGS-zs8-1 and other distant galaxies, offering further insights into the early universe. In conclusion, EGS-zs8-1 stands as a beacon from the dawn of time, shedding light on the processes that shaped the first galaxies. Its discovery underscores the importance of galaxy interactions in the early universe and opens new avenues for exploring the cosmos's ancient history.